An icon rises in the New York City skyline. One World Trade Center, 104 stories tall, reaching a symbolic 1,776 feet. It's been an epic journey, filled with troubling problems and innovative solutions.
We're really at the cutting edge on everything at this site.
This building is not a skyscraper. It's taller than a skyscraper. This is in another league.
For architect David Childs, it's the challenge of a lifetime.
We knew this building would have all eyes on it, and it needed new technical advances that would set the path for other buildings in the future.
Next door is the 9/11 Memorial, to honor those who died in the worst terrorist attack in American history.
Future generations need to understand what took place at this site.
And 70 feet below ground is the 9/11 Museum.
The role that this museum plays is really to punctuate what that day means for you.
After more than a decade, the building of One World Trade Center is almost complete.
It is very important that we did rebuild. It gave us a chance to rebuild better.
We have the DNA of strivers. That's part of the American character. And so there's this desire to rebuild tall again.
It's the birth of an icon. But will it live up to its promise to be beautiful, safe, and ahead of its time? Ground Zero Supertower, next on Nova.
Major funding for NOVA is provided by the following: the David H. Koch Fund for Science, supporting NOVA and promoting public understanding of science, and the Corporation for Public Broadcasting, and by PBS viewers like you. Thank you. And by
a beacon rises. 104 stories, up to the top of the tallest building in New York. Perhaps the tallest building in the Western Hemisphere.
Going back into the sky is really important because that's something that was taken away. And I think it's appropriate to put it back to show that the life of the city goes on and is more powerful than the forces that attacked it.
Its creators' hopes and dreams are riding on it being not only the highest, but the safest, most innovative and beautiful skyscraper in America.
I feel a great sense of accomplishment. This building is a strong visual image of our resilience, coming back after this terrible tragedy.
The tragedy was the worst terrorist attack in American history. September 11th, 2001, causing unimaginable destruction, killing almost 3,000 people. Out of the ashes, one of the world's most innovative skyscrapers is rising. Soon, its beacon will illuminate the New York City skyline.
You're going to look up there, and you're going to identify with 9/11, with One World Trade Center, as a result of this beacon of light.
I know for me, wherever I am and I can see that light, I'll know that as Americans, as architects, as New Yorkers, that we have resiliency. We've triumphed. We've come back. We've built this. We're reaching for the stars.
It has taken over a decade to lift this beacon a symbolic 1,776 feet to the top of One World Trade Center. But it is just one of the many challenges architects and engineers have faced on this 16-acre construction site, known as Ground Zero. Today, it is bustling with activity, from hundreds of feet in the air to 7 stories below the ground.
12 years ago, people thought nothing would ever happen here. 4 years ago, people think nothing was happening here. And now, people know that this site is back.
When complete, the site will include a train station to rival Grand Central, 6 new towers, and at its heart, the 9/11 Museum and Memorial, built in the footprints of the twin towers of the World Trade Center that once stood here and were destroyed in the attack.
We owe it to those that didn't get to come home. We didn't coach another Little League game. We didn't get to see their kid get married. That's why we're doing it.
And so, as the Port Authority of New York and New Jersey build this super tower, safety is paramount, and a new approach is required. Back in their day, the Twin Towers were considered state-of-the-art. They employed a unique steel structure that allowed for wide-open floor spaces, where up to 40,000 people went to work each day. But decades later, these marvels of engineering proved vulnerable in a way no one had foreseen. Architect David Childs watched the events of 9/11 unfold from his office in downtown Manhattan, where at 8:46 a.m. the North Tower was struck by an airplane. Then the South Tower is hit. Both buildings are in flames.
I remember walking up to a window, and a young man turned to me with tears coming down his face, and he said, "Will they fall down?" And I said, "No," right away, because I knew that if they hadn't been knocked over, they wouldn't fall down. The fire would be put out. Never has a steel structured building in the history of steel structured buildings ever fallen down for the reasons of fire.
Never before had a steel structure under fire absorbed the loss of such massive columns from an impact. At 1,800 degrees Fahrenheit, it's hot enough to weaken the steel structure. The North Tower stands for an hour and 42 minutes. The South Tower for only 56. Finally, the steel gives way to the heat. The floors start to sag. The perimeter steel columns buckle. The Twin Towers do the unthinkable. They collapse. Nearly 3,000 people die. Several months after the attack, David Childs starts to think about designing a new tower at Ground Zero. It is the challenge of a lifetime, to come up with a building strong enough and safe enough to be built on this site.
Safety has always been a measure of how buildings are built. Go to Florence. Some of the great buildings of Florence are all about defense. Great pieces of rusticated stone, of metal bars across the windows. And yet you look at those buildings and you think proportion and texture and shade and all the interaction of the different materials. You don't think about safety today.
Childs hopes to achieve the same balance through innovation.
We needed to investigate and invent new ways to show how buildings could be built in the future. So this building must look forward in terms of new technology, new inventions. How do we make the ideal building of the future look forward?
As he looks for ways to answer this question, Ground Zero is in ruins. Rescue workers are desperately searching through the rubble for the remains of those who were still unaccounted for. When beneath more than 1 million tons of debris, engineers discover another disaster waiting to happen. The site is at risk of being inundated by the Hudson River, only a few hundred feet away.
Many people aren't aware that this site at one point was underwater. It's landfill. Over time, docks and wharves and landfill slowly increased the tip of Lower Manhattan. What this means is that the site that was occupied by the World Trade Center is literally in water.
To build the world's tallest towers on land like this, engineers had to find a way to keep the river out. They came up with an ingenious idea.
This entire complex was built inside what we call a slurry wall.
The slurry wall encircled the World Trade Center complex like an enormous bathtub.
A bathtub where the World Trade Center site was built within, and it essentially kept out the Hudson River, it kept out all the wet soil surrounding the site.
The slurry wall was made up of over 100 panels, each one 22 feet wide and 7 stories deep, going all the way down 2 feet below bedrock. Each section was excavated and filled with a gluey clay mixture called slurry, which keeps silty soil and water from getting in. Next, a 70-foot-long steel frame weighing 22 tons was lowered into the slurry-filled panel. Concrete was slowly pumped into the panel, and the slurry, which is much lighter, rose to the surface and was pumped out. When the concrete hardened, they repeated the process over and over again, forming a massive underground wall.
Once the wall is built, they proceed with the installation of tie bags. These tie bags actually hold the wall to the rock.
Tie bags are long steel rods that go all the way down to bedrock to support the wall.
They become diagonal structural elements that pull the wall to the rock.
So the whole site is basically a bathtub pushing back the waters of the Hudson.
After 9/11, it looked as though this enormous bathtub might have been weakened and could collapse.
There was real concern that this wall was going to be breached.
These walls are coming in. They moved in about 6 inches, and these walls hold back the river. So if these walls cave in, this place is going to get flooded out by the river.
A disaster that was already incalculable in terms of the human loss and the loss to just lower Manhattan and New York City would have gotten that much worse.
Securing the slurry wall became a top priority. Soon, engineers discovered that the 1.8 million tons of debris filling the bathtub were actually preventing it from collapsing.
The debris was actually acting as a barrier to keep the wall in place. That's why we couldn't just remove all the debris. We have to remove it in lifts, in pieces. And we did this like a mining operation around the entire pit. And every elevation of debris we removed, we had to install new tie bags. Once the new tie bags were installed, we felt more comfortable that the wall was now secured properly, was structurally sound.
A new liner wall was built right in front of the original. But a section of the old one has been left exposed as a reminder of what happened here.
The very last piece of steel to be removed from the site, the last column, was removed on May 30th of 2002, and it signified the end of the recovery period.
The recovery period is over. The slurry wall secured. Nearly 2 million tons of debris removed. Now, the site is empty. There is a gaping hole in the New York City skyline, and no one can agree on how to fill it.
Everyone had a different idea and a different vision of what should happen there. Some important figures didn't want any memorial, wanted the whole thing redeveloped. Others said you can't develop anything down there, it all has to be preserved. So pulling everything together was not an easy task.
It was certainly frustrating as to how long it took, although remember, Central Park was probably 20 years late and 6 times over budget, and nobody remembers that. The question is, where are you, not how you got here.
David Childs, along with partner T.J. Gottesdiener and a team of architects and engineers, are in the thick of it, rethinking strength and safety from the inside out, starting at the core. The core of a skyscraper is a backbone that runs up the center. It provides structural support and strength. Child's design for the core of this supertower will use one of the strongest, most fire-resistant materials around: concrete. But this isn't just any concrete. This concrete needs to be so strong, it means going back to the lab to develop it.
This is a concrete specimen that will be used for Tower 1 at the World Trade Center. If you could set this cylinder and put a platform on it, you can accommodate 1,000 Americans standing on this cylinder. You know, normal people, 175 pounds in weight. 1,000 people can be supported by this 4-inch diameter cylinder.
Concrete is made of sand, stone, and binding agents like lime or cement that, when water is added, hold the mixture together. But the recipe can be revised by using less water, replacing it instead with chemicals that keep the concrete moist without reducing its strength.
Water makes this concrete move in place, but you can't have too much water, because when you have too much water, the strength goes down.
The goal? To make concrete that can withstand loads of up to 14,000 pounds per square inch. Normal concrete is about 4,000 psi. Even the Hoover Dam is no more than 7,500. But strong concrete has its own challenges. It hardens quickly, so it's a race against time to get it into place before it sets. Driver Eric Zempel has only 90 minutes to get the job done.
Concrete is a perishable item. We have like an hour and a half to get the load off.
By 2006, this super strong concrete makes its way to Ground Zero, where construction has finally started. Crews have less than an hour to pump it through an elaborate system of hoses where it is poured into a mold and secured with steel bars, called rebar, that give the concrete something to latch onto. The hope for this reinforced concrete is that it will withstand unforeseen challenges in the future.
It's strong. That's why I call it liquid steel.
When finished, one World Trade Center will contain almost 500,000 tons of this liquid steel, much of it in its core, which has walls up to 6 feet thick.
The outside of the core, this whole center spine of the building is out of concrete.
The cores of the Twin Towers were compromised on 9/11 because they were made of steel wrapped in thin sheetrock.
Where the planes hit, that sheetrock was not strong enough to take that punching shear.
At the point of impact, the stairs were destroyed, leaving nearly 2,000 people trapped above, with no escape. That's why it's critical for one World Trade Center to have a super strong concrete core, well beyond existing building codes. Inside, the core protects a total of 73 elevators. Some can travel 23 miles an hour, making them the fastest elevators in the Western Hemisphere. The core also has staircases that are extra wide and pressurized to keep smoke out.
When a door is open, that pressure goes out, keeping the smoke away from it. And that's a very effective thing. Smoke is a real killer.
One World Trade Center's concrete core is designed to avoid the tragedy of 9/11, where 2/3 of the victims died because they couldn't get out of the building. And nothing will remind us of that more than the 9/11 Memorial and Museum being built next door. The entrance of the museum will be at ground level, but the heart of it is being built 70 feet below the surface.
The overall museum is about 120,000 square feet, except for the entry pavilion. It's underground. At bedrock, it's about 95,000 square feet.
Here, parts of the Twin Towers foundation are carefully preserved, like a section of the original slurry wall, and these huge girders that supported the floors above.
These are the original box beams. These are the original structure that held up the columns, that held up the North Tower at the north face. I kind of consider them almost like a dinosaur skeleton. You know, you look at it and you wonder what was.
This museum is an archaeological space as much as it is a museum. So when you go to bedrock and you see the very footprints where the towers sprung to life, it is sacred bedrock. These buildings soared more than 1,300 feet into the sky and defined the New York skyline. This notion of authenticity of place, it was super important to us.
You're standing on bedrock. This is as low as the structure of the World Trade Centers were, so this is pretty magical right now. It's becoming more of a construction site and less of a disaster zone.
The museum will house artifacts that have been stored for over a decade in an old hangar at New York's JFK Airport.
Engineers and architects who went through the debris had the charge of identifying remnant pieces of the buildings that could help scientists better understand what happened. They also were looking for things that might someday help reconstruct the events.
In twisted steel and broken beams, the full scale of what happened on 9/11 can be witnessed.
This material filled an 80,000 square foot airline hangar. What was in that hangar represented less than 1% of what was at the site, and it filled it to capacity. So just walking into the hangar, you had a sense of just the enormity of what had happened.
Some of these artifacts are so large, they are brought on site before the museum is finished, so it can be built around them. Like these 7-story tridents. These enormous pieces of steel, which weigh 50 tons each, formed the distinctive Gothic arch motif at the base of the Twin Towers. So many tridents survived the attack, their silhouette has become a symbol of strength. In 2010, 2 were brought on site and set in place.
The 2 we chose were, in fact, side by side on the North Tower. So you have a twin presentation. They embody a kind of memory of the twinness of the Twin Towers.
Over the next few years, the entrance of the museum will be built around them. Almost 1,000 artifacts from September 11th will be on display at the museum. This fire truck, wrapped in plastic, is lowered through a hole in the roof, 70 feet down. It's from the fire department's Ladder Company 3, which lost 11 of its own while helping evacuate others. Each artifact tells a story. Like this mangled piece of steel called M2 that was located where the first plane, American Flight 11 from Boston, struck the North Tower. It is a chilling reminder of the moment the attack started. Now, it is hoisted up and set in place.
Future generations need to understand what took place down here. When they see a piece of steel bent and twisted like that, they can now begin to understand the amount of destruction, the amount of sadness that came upon this site.
Next door, at One World Trade Center, a one-of-a-kind structure is taking shape. 20 stories high, the podium base is designed to be strong enough to survive a massive truck bomb. And unless the base of the building is super strong, it could also be hard to attract renters. The podium has thick concrete walls that are reinforced with large steel columns. Not only is it strong, it will look strong enough to be a deterrent.
One of the things that I've learned about safety is the appearance of safety. If somebody looks at a building and says, boy, that looks pretty flimsy, they're interested in it. If it looks tremendously strong, you say, well, let's go pick on somebody else.
But there's a cost to this approach. David Childs does not want to create a fortress. In an attempt to make the podium more inviting, he designed soaring entryways. Behind them, giant concrete blast walls protect the lobby. But Italian marble will hide their true purpose, and large openings will allow sunlight to stream in.
Because of the nature of the destruction that was here before, you don't want to give the impression that this is a place of refuge and of fear. You want it to be a sense of openness to it. This building needs to appear open.
So he decides to cover the podium with a kind of glass that reflects light like a prism. The glass will have to be cut in a way that could compromise its strength. It's a unique challenge, but not the only one. Creating panels of glass big enough to start with is also tricky.
This glass is 1 inch thick glass, 130 inches wide and 159 inches long. Each individual piece of glass is 1,800 pounds, almost a ton of glass in one single piece.
To create these one-of-a-kind panels, they start the old-fashioned way. Take sand, combine it with other ingredients like lime and baking soda, and put it in a furnace at temperatures nearly 3,000 degrees. The intense heat turns the mix into liquid, which is then poured onto molten tin. The glass appears as a red line floating on top. On rollers, on a line almost 1/4 of a mile long, the glass cools and strengthens. But if conditions aren't perfect, neither are the panels.
And you can hear that glass in the background just going down. So even though we look at this as a momentary disaster in our process, that told us what we need to do to make the correction in an engineering sense.
At the end, it's cut into those large panels. Next, these enormous panes of glass are placed on ships and sent halfway across the world to China, where they design special machines to cut grooves into the glass. But will it hold up? For such a high-tech product, the test is simple and revealing.
3, 2, 1.
It's no surprise that it breaks, but it's designed to stick together like safety glass.
3, 2, 1.
Instead, it shatters into dangerous shards.
All right, as you can see, the debris are pretty big. Something like that would fall on your head would not be pleasant.
You know? So this is why we do these kind of tests.
When the results reach New York, the news is heartbreaking. This building is David Childs' legacy. He needs to find a new solution for the podium glass that will be both safe and beautiful. Above the podium, Childs is getting much better results. One World Trade Center is rising a floor a week. Inside, there is a steady rhythm of work. Build out the floors with concrete, spray with fireproofing, lay elevator tracks in the corners.
All the way to the very top.
As the core rises, on the outside, One World Trade Center is starting to take on its distinctive shape. The podium is a square, about the size of the original towers. At the 20th floor, the corners taper in. A square becomes an octagon. 4 sides become 8 interlocking triangles. Finally, at the top, it resolves in a square once again.
The profile, as you look from the memorial, is identical to the old, but as you walk around it, you see the corners tapering in. It's a new modern building, but it has a memory of what was lost.
To achieve this subtle shapeshift, Childs turns to steel, 45,000 tons of it.
Steel is relatively light, it's flexible, you can do all sorts of things with it, it's supple, it's a wonderful material.
Almost a quarter of it, 10,000 tons, starts here, Coatesville, Pennsylvania. One World Trade Center is designed to be a certified green building. Steel contributes to that because much of it comes from recycled materials like old refrigerators, cars, even toasters, all melted down into liquid. Then it's poured and molded into giant sheets. The sheets are carefully cut, welded, and shaped to make pieces that fit in a specific place in the building. Some of the largest are called nodes. They can be as large as 60 tons and stand 3 stories high. Nodes are giant joints that hold multiple pieces of steel together. They come in all shapes and sizes and make it possible for the building to shift form from 4 sides into 8. And they also help redistribute the weight as the building rises. Back at the site, a critical node is ready to be hoisted into place.
Get it as close as you can to the ring.
Working with steel this big takes experience. Peter Jacobs is a member of the Mohawk Nation, famed for their work on skyscrapers and bridges for over a century. He is a 5th-generation ironworker, a member of an elite group called the Raising Gang. Their work starts at the base of the building, where they move giant crane hooks called chokers into place. 2 cranes lift the massive 40-foot-high node hundreds of feet up as the Raising Gang guides it into place.
It's a dangerous job, Connect. It's the most dangerous job out of all of them. If you ain't got the heart, that's the whole key to it. Right in there.
The work of the Raising Gang hasn't changed since steel frame construction began over a century ago. Neither has the next gang to take possession of the massive node. The Bolting Gang. Their job, to mercilessly pound and bolt the node into place.
If things are off by 1 or 2 or 3 inches, we bring out the big boy. Show them the big boy. Show them what you got. Big boys, yeah. That pulls everything. That pulls the entire building in the plumb.
It's the plumb up gang that makes sure every column is perfectly plumb, perfectly vertical.
It's a game of less than inches. It's a game of quarter inches.
The plumbness of a building is critical.
Our tolerance is probably 1 inch on a column, and we try to keep everything even within a ½ inch of where it's supposed to go. So it's quarter inches and 8ths and 16ths. It's not inches.
The slightest mistake, and the building will tilt. Finally, the welding gang completes the joint.
When you first start walking the steel, you're like, all right, looking around you, look how high up I am. But after a while, you're focused on your work. You really don't think too much that you're 700-800 feet in the air.
A steel worker's nerve leads the way up a super skyscraper. Story after story, the steel goes up. The concrete core, which gives One World Trade Center its strength, follows several stories behind. Until the core catches up, the steel frame needs stability. To solve this problem, Larry Davis at DCM Erectors comes up with a novel idea.
We saw this great big space and we said, well, maybe we can put something in here.
So Davis puts cargo containers between the steel beams and outfits them with tables and chairs where construction workers go on breaks. He calls them hotels.
We built like a little city where we have washrooms, workstations.
Even a subway shop where crews go for lunch.
To go to the top with some of the hoists took a substantial amount of time, especially with 1,200 workers each and every day, moving around throughout the building, up and down.
With only a half hour for lunch and up to an hour's commute from the top of the building to the base, the hotels are a real time saver for workers.
So that's our accommodation for the job, which works well because of the height of the building.
Another problem building high, equipment and tools can hurtle more than 1,000 feet onto construction workers or pedestrians below. To prevent this from happening, Davis designed a fireproof, steel-framed net that covers the exterior of the top floors of construction.
The cocoon system provides tremendous worker safety and prevents anything from coming off the building.
The hotels, 2 cranes, and the cocoon climb the super skyscraper in unison.
We can climb the crane in 2 hours, and we can climb all the hotels in 4 hours, and the cocoons climb in about 6 hours.
As One World Trade Center makes its way into the New York City skyline, right below, another extraordinary structure is taking shape, the 9/11 Memorial, the vision of architect Michael Arad. This design calls for 2 pools in the footprints of the original towers, surrounded by a forest of trees.
It was an idea that was just in my head, and then on a piece of trace paper, and then eventually I ended up building a small fountain on my rooftop.
He calls it reflecting absence.
Using the footprints of the 2 towers as the starting point for the memorial is actually very powerful symbolism. Where there was presence, there is now absence. Where there was solid, there is now void.
Each pool is 30,000 square feet.
You could not imagine the scale of it unless you're looking at it right here.
They are lined with granite from a quarry in Virginia. Almost 5,000 tiles must be laid in a specific order, so there is a continuous pattern to the grain.
Just look at that stone. If you could just imagine the lines not being there, it looks like one stone. Look at how that grain just flows. It's almost as though this stone is a continuation of this stone. The adjacent piece looks like it belongs next to it.
When the pools are complete, 52,000 gallons of water will cascade over the walls every minute, drop 30 feet, and disappear into a second inner pool.
We didn't want to create a torrent. This is not about being behind Niagara Falls. It was always about creating something that is gentle yet persistent. And then the question is, how do you make that idea take shape?
The solution arrives on site. It's called a weir. Weirs are normally used to alter the flow of rivers to prevent flooding. But here they need to move water into the shape of an architect's vision. The weirs are there to push it outward just far enough to give it a gentle arc, to make it fall in a neat cascade. Now in place, the weirs are ready to be tested. It's time to turn on the water. Workers carefully watch as water starts to flow through the system into the troughs by the side of the pool.
Things are holding pretty good, so we're gonna go ahead and let it go over. What's this coming over there?
It's starting to go over here, too.
Yeah. That wall, that looks, the wind is doing
There
it.
it goes.
It's beautiful. It's moving. I am at a loss for words.
But the hardest part is yet to come. In Dover, New Jersey, powerful water jets engrave the names of the 2,982 individuals whose lives were lost on 9/11. The names are not listed alphabetically, but by the locations where individuals died. The South Tower, the North Tower, Flights 11, 93, 77, 175, and the Pentagon. First responders and those who died in the 1993 attacks are also grouped together.
It, in essence, does tell the story of what happened, largely by the way in which the names are arranged. So when you go, you'll actually be able to sort of peel back and understand the story a little better.
50% of the folks that are on the memorial, no remains were found. And so this is going to be, for many families and many loved ones, the place that they'll go on those special days, the birthdays, the anniversaries. Unfortunately, this is their final resting place.
It's heartbreaking, really. Look at all these people. You know, the pain them and their families endured. Sad. I mean, it is, but we gotta get a job done.
As 152 bronze panels are carefully etched, hundreds of trees are being prepared to be taken to their new home, Ground Zero. They originally come from the three places where people died: New York, Pennsylvania, and the Washington, D.C. area. They will become part of an 8-acre forest on the Memorial Plaza. Beneath the plaza, a complex irrigation system has been devised to bring water and fertilizer to each and every tree. But what makes this system truly advanced is the sensor technology embedded in the soil.
These trees have their own computer chip in them. They have their own monitoring system for aeration and irrigation. I mean, each tree has its own little ecosystem. So we know how they're doing. It's all high tech, real high tech, and yet when you look at it, it's just a beautiful little forest.
16 trees weighing 18,000 pounds each are being hoisted and prepared to move.
It's a magical time today. There's nothing like planting a tree.
The trees arrive at Ground Zero just in time for the memorial to open on the 10th anniversary of 9/11.
The memorial is a place of reflection and remembrance, and there's something positive in that out of such tragedy, we were able to do something that is really beautiful. And for the families and friends of those who are lost, it is a place to remember the lives that these individuals lived.
One of those individuals, David Berry, was on the 93rd floor of the South Tower when it collapsed. Ever since, his wife Paula has dedicated herself to seeing the memorial come to fruition.
I find it really heartening to see all these tourists come wrapped in ponchos with their umbrellas, knowing full well they're coming to see it in the rain. This was a disaster area and then a construction site. But I think it's become a place of contemplation. People will take away the magnitude of the event and the loss.
By the 10th anniversary in 2011, the super tower had reached 80 stories, and huge panels of glass were starting to cover the exterior. Over the next several years, these enormous panes of glass, called the curtain wall, will make one World Trade Center impermeable to the elements of its surroundings, except for one: wind.
When you build buildings of this height, you now begin dealing with a whole new set of criteria. One of the things is the sway of the building. And that sway comes from wind, the wind pushing it back and forth.
When wind hits a rectangular skyscraper, it pushes against the flat surface and creates turbulence around the sides, and that causes the building to sway. But One World Trade Center's unique design means the wind is not a problem.
This building is tapered at the corners, so that as the wind hits the top, it confuses the wind.
Instead of hitting a broad, flat surface, the wind flows around the tapered corners in a more gentle way, and that reduces the turbulence and the sway. And there's another reason this super tower has so little movement.
The building has so much redundancy of structure and strength of the core of that center spine with concrete supporting it. It naturally is a very, very stiff building.
At its base, where its builders claim One World Trade Center is stronger than any skyscraper ever built, a solution has finally been found to the prismatic glass, which shattered when put to the test.
This is a small sample of the glass, and it's literally 3 layers of glass laminated together, different qualities of glass and thickness for strength and rigidity. But what happens is you get this beautiful quality and beautiful opulence to the glass.
Over the next few months, thousands of panels of glass will cover the entire base of the building. But unlike the curtain wall above, they're not flat. In order to let air in and out of the mechanical systems behind them, the panels open up.
It's not just a skin, but there's a depth to it that gives you the opportunity of being something which is breathable and open and in a way welcoming.
Although this podium glass was not David Child's original vision, he knows that no project as complex and innovative as this can be completed without its trials.
At the end of the day, nobody will recognize all of those trials and difficulties of getting these things all to be solved in a simple building, but to have this building as a serene a form as possible was terribly important to me as a designer.
By the summer of 2013, the 9/11 Museum is also on its way to completion, scheduled to open in several months.
Wow, this is so different from when I was here last. It really is beginning to look like a museum. And you can see how huge this space is. It is cavernous. This is an overlook, the first time you get to see the slurry walls, and it always sends chills up my spine. This to me is resilience. This is resilience. These are the survivors' staircase. Many people within the building use these stairs to get out. They represent they represent those people who were saved.
When people come to this museum and they see the worst of humanity in the attacks that took place, they're also going to see the best of humanity. The first responder vehicles that we have in this museum, they are so powerful because they tell the story of the sacrifice and selflessness of so many. And I think for our children, for people from around the world, knowing that, it's a comforting thing.
Just before winter descends on the New York harbor, a barge makes its way down the Hudson River, past the Statue of Liberty. It is carrying precious cargo. The first 9 sections of the One World Trade Center spire. It has taken a month for them to make their way from Quebec to their final destination, Ground Zero. The next morning, The heaviest piece, the 67-ton base, is lifted to the roof. 1,368 feet.
It's nice to be a part of it. Finally, we're reaching it, and it's symbolic. Everybody knows that, so I'm excited and proud to be here.
Over the next several months, the remaining 15 sections of spire are lifted to the top of the super tower and assembled.
It just means the world. It's a major step forward. It's, you know, it just puts everything back to where it should be.
And finally, the last 2 sections of the spire, including the beacon, are lifted to reach a symbolic 1,776 feet. For the thousands of workers who built this tower, it's a moment to savor.
When it was bolted into place, the construction workers and everybody on the roof spontaneously broke into cheers and applause. It was a breathtaking moment.
On the 12th anniversary of 9/11, construction at One World Trade Center is almost finished. Ground Zero is nearing completion. The end is in sight.
Yeah, it's going to be one hell of a landmark, you know, because you can go back, point it out to your kids or your grandkids someday, say, I worked on that, I helped build that building, you know.
Already people are visiting here from all over the world. Soon, they will work here. Life has returned to Ground Zero.
People will know intuitively where they are when they come here. They'll know what was here. They'll know the loss that is here. And yes, you still feel that loss, but it's a place of healing.
In years to come, this sacred ground will take on new meaning that we can't now foresee. But the way Ground Zero has been designed and built makes one thing certain. What happened here will never be forgotten.
This NOVA program is available on DVD. To order, visit shoppbs.org or call 1-800-PLAY-PBS. NOVA is also available for download on iTunes.
An icon rises in the New York City skyline. One World Trade Center, 104 stories tall, reaching a symbolic 1,776 feet. It's been an epic journey, filled with troubling problems and innovative solutions.
We're really at the cutting edge on everything at this site.
This building is not a skyscraper. It's taller than a skyscraper. This is in another league.
For architect David Childs, it's the challenge of a lifetime.
We knew this building would have all eyes on it, and it needed new technical advances that would set the path for other buildings in the future.
Next door is the 9/11 Memorial, to honor those who died in the worst terrorist attack in American history.
Future generations need to understand what took place at this site.
And 70 feet below ground is the 9/11 Museum.
The role that this museum plays is really to punctuate what that day means for you.
After more than a decade, the building of One World Trade Center is almost complete.
It is very important that we did rebuild. It gave us a chance to rebuild better.
We have the DNA of strivers. That's part of the American character. And so there's this desire to rebuild tall again.
It's the birth of an icon. But will it live up to its promise to be beautiful, safe, and ahead of its time? Ground Zero Super Tower, next on NOVA.
Major funding for NOVA is provided by the following: the David H. Koch Fund for Science, supporting NOVA and promoting public understanding of science, and the Corporation for Public Broadcasting, and by PBS viewers like you. Thank you. And by
a beacon rises 104 stories up to the top of the tallest building in New York, perhaps the tallest building in the Western Hemisphere.
Going back into the sky is really important because that's something that was taken away. And I think it's appropriate to put it back to show that the life of the city goes on and is more powerful than the forces that attacked it.
Its creators' hopes and dreams are riding on it being not only the highest, but the safest, most innovative, and beautiful skyscraper in America.
I feel a great sense of accomplishment. This building is a strong visual image of our resilience, coming back after this terrible tragedy.
The tragedy was the worst terrorist attack in American history. September 11th, 2001, causing unimaginable destruction, killing almost 3,000 people. Out of the ashes, one of the world's most innovative skyscrapers is rising. Soon, its beacon will illuminate the New York City skyline.
You're going to look up there, and you're going to identify with 9/11, with One World Trade Center, as a result of this beacon of light.
I know for me, wherever I am and I can see that light, I'll know that as Americans, as architects, as New Yorkers, that we have resiliency. We've triumphed. We've come back. We've built this. We're reaching for the stars.
It has taken over a decade to lift this beacon a symbolic 1,776 feet to the top of One World Trade Center. But it is just one of the many challenges architects and engineers have faced on this 16-acre construction site, known as Ground Zero. Today, it is bustling with activity, from hundreds of feet in the air to 7 stories below the ground.
12 years ago, people thought nothing would ever happen here. 4 years ago, people think nothing was happening here. And now, people know that this site is back.
When complete, the site will include a train station to rival Grand Central, 6 new towers, and at its heart, the 9/11 Museum and Memorial, built in the footprints of the twin towers of the World Trade Center that once stood here and were destroyed in the attack.
We owe it to those that didn't get to come home. We didn't coach another Little League game, didn't get to see their kid get married. That's why we're doing it.
And so, as the Port Authority of New York and New Jersey build this super tower, safety is paramount, and a new approach is required. Back in their day, the Twin Towers were considered state-of-the-art. They employed a unique steel structure that allowed for wide-open floor spaces, where up to 40,000 people went to work each day. But decades later, these marvels of engineering proved vulnerable in a way no one had foreseen. Architect David Childs watched the events of 9/11 unfold from his office in downtown Manhattan, where at 8:46 a.m., the North Tower was struck by an airplane. Then, the South Tower is hit. Both buildings are in flames.
I remember walking up to a window, and a young man turned to me with tears coming down his face, and he said, "Will they fall down?" And I said, "No," right away, because I knew that if they hadn't been knocked over, they wouldn't fall down. The fire would be put out. Never has a steel structured building in the history of steel structured buildings ever fallen down for the reasons of fire.
Never before